Thank you for joining us on this second recording for unlocking the value of System Center and Azure Pack for the Microsoft UK in Ireland MVP series with the Register. In this second video of the series, we're going to take a much closer look at the building blocks that are required to allow us to deliver management scenarios using one or more of the components which comprise the System Center suite itself. My name is Damian Flynn. I'm a Microsoft MVP focused on System Center, Cloud and Data Center Services. I'm 5 years MVP with history on Microsoft private cloud technologies and co-authoring books on the subject covering both the System Center components, the Hyper-V services, and the much newer software-defined functionalities of networking, leveraging both Cisco, Microsoft, and F5 technologies. You can find me online on damianflynn.com, on tweeting at @DamianFlynn, or of course through the email systems at info@DamianFlynn. In this session, we're going to take a much closer look at the actual building blocks of the Cloud OS. What is it that makes System Center? What are all these modules, and how do I make use of them? And now that I understand what all these modules are, what are some of the scenarios that I can use in my day job and in the real world to make these components provide business value in my deployments? Now, on your very first experience with System Center, you're going to be forgiven for wanting to rip your hair out, or if you're like me, may not have any hair left to rip out. But the reality is, when you start working with the Microsoft technologies, your very first learning curve is going to be sorting out all of the different anagrams. System Center is no different from most of Microsoft technologies and comprises of a number of different components. Each component can be referred to through its full name or through a short name. And in many cases, these do not really help us to understand what the different components are. For example, some of the names you're going to come across over the course will include SMA, WAP, OM, SCOM, ASC, VMM, SCVMM, and so on and so forth. Understanding what each of these different components are and what the anagrams that associate with them is the first step in figuring out the building blocks that is the Cloud OS. Once you have an understanding for what each of these different components offer and has the ability to deliver to you as a user or as a consumer of your business resources, will help you to understand how to correctly instrument your environment and with which components to instrument with first. Over the next 10 or 15 minutes, we're going to spend a little bit of time and talk about some of the more common anagrams or components that exist in the current revisions of the System Center suite. And by current, we're going to refer to System Center 2012 and 2012 R2. In addition to the 2012 SP1, there's been a number of small but minor changes to the components that have been included in the product suites over that previous 3-year period, and also allowing us to see the framework for what might be coming down the line as we move forward. System Center is also becoming cloud aware, so we're going to see more and more technologies that aren't even listing on our anagrams list here. Things like Advisor, which has now become known as Operations Insights, and what those are and how they also affect our environment. So, without further ado, let's start with the top of the list, and the very first anagram that we're going to hit off today is SCVMM. System Center Virtual Machine Manager. Virtual Machine Manager is essentially one of the core components in the System Center suite, first introduced in 2007. Virtual Machines Manager primary focus was obvious, to manage virtual machines. However, managing virtual machines doesn't simply refer to the process of starting a virtual machine, stopping a virtual machine, deleting a virtual machine, or even provisioning a virtual machine. Virtual machines are far more complicated. You have a fabric that is required first and foremost to support and allow us to deliver those services. A fabric happens to be the components that are delivered in our data center or in our server rooms. That will include things like network switches. It will include routers, load balancers, servers, those pieces of hardware or infrastructure that are necessary to be placed into production prior to delivering our first virtual machine. Failure to deliver these in a proper process will mean anything that we run on them, our virtual machines in this scenario, will be inherently unreliable. So we must start with a strong fabric and a good base to build everything from. One of the key features of Virtual Machine Manager is fabric management. It has the ability in the box to do bare metal deployment, which essentially refers to the idea or concept of booting a brand new piece of kit off the network, delivering it a new operating system based on a standardized image which we as the system administrators have designed and configured, and then take that base image, restart the machine automatically for us, hands off, bring the machine online, configure its networks using predefined standards that are configured in our fabric, join that configured machine into a cluster, and associate any storage requirements that are necessary, including the ability to communicate with the storage array and tell the storage array that this new node has to be granted access. For example, in a fiber channel scenario, we may not need to unblock paths. In an iSCSI scenario, we may need to provide a connection back from the host to the iSCSI targets, or even simply standalone storage and just instructing the server where it is to place its virtual machines. Once we've managed our fabric, Virtual Machines Manager next role comes into that of setting boundaries, groups, and configurations around the provisioning that is necessary to deliver virtual machines. Rather than allow us to deliver hundreds and hundreds of virtual machines on top of the servers that form and deliver our fabric, we need to put boundaries around it, access controls, restrictions, and hence the procedures for building what are multi-tenant clouds. Clouds essentially contemplating the idea of grouping servers and resources of the same type together, and tenants offered capacity from those resources to essentially host and manage their virtual machines. To keep things standardized, rather than allowing us to spin up a virtual machine at will, we will utilize libraries and templates, and in these templates define the sizes of the virtual machines, the disk, the memory, the networks which they connect to. We will configure the actual networking models of how the environment is connected both physically and virtually, and we will also deliver role-based controls, allowing us to delegate administrative privileges to different administrators or to different tenants so they can control and manage the resources that have been provisioned within their clouds. Delivering on a cloud scenario, we also have the requirements for self-service. Our users need the ability to be able to come in and request the virtual machines through a self-service experience and have virtual machine managers run its automation procedures to deliver that VM, all within the confines of the quotas that have been assigned to that user, and effectively provide the user with the ability to control and maintain its environment completely isolated and agnostic to any other users that may be working in the environment. The ability to share resources within teams is also something that will be of importance to us. So the experience that the user will be offered for his self-service is something that we will need to consider. This is an experience that we will look at next, and that comes in the form of System Center Application Controller. SCAC. App Controller was introduced in 2012. Prior to Application Controller, Microsoft's Virtual Machine Manager 2008 or 2 shipped with an in-box web portal known as SCVMM's portal, quite simply. This was further enhanced with System Center's self-service provisioning portal, which was a Windows accelerator available for free, allowing us to do some additional functionalities on top of the inbox features. Both of those technologies have since been depreciated, and with the release of System Center 2012 SP1, the inbox version of the VMM portal no longer exists or being supported. Application Controller, a Silverlight-based client, offers a rich experience for users to communicate with Virtual Machine Manager in a self-service experience. But it doesn't stop with just Virtual Machine Manager. Application Controller has also been enhanced with the ability to also communicate with virtual machines hosted on the Windows Azure platform. Application Controller is Microsoft's first product to bridge the self-service experience for both on-premise and public cloud services, referring to Virtual Machine Manager or to Windows Azure. Utilizing library technologies, those libraries or virtual machines hosted in each of these different resource pools can now be migrated from location A to location B, on-premise or off-premise, through this App Controller experience. App Controller is currently in the process of being depreciated, which might sound a little bit shocking given the fact that it was only introduced in 2012, but we'll take a look a little bit later at some of the new steps and what's coming to essentially replace the functionality in App Controller, and also to understand a little bit why. Well, the first and probably primary driving reason for that is the fact that App Controller is a Silverlight based client, and it is, hint hint, being replaced by a service that is HTML5, therefore is much more widely supported on different platforms and browsers. As we continue our tour of the different System Center components, we're going to take a look at a module known as Service Manager, SCSM. Now, Service Manager fills a completely different gap. Service Manager's focus is on ITIL, the IT operations processes. Its focus is to help us run our IT operations as a help desk type service, contemplating things like service level agreements, taking our services and delivering them as offerings to our users. So in a combined scenario to what we've just seen as a self-service experience for Virtual Machine Manager, we're now looking at Service Manager as being a self-service experience for all other service requirements. Users requesting support for mail or for any other business services we require to deliver. But Service Manager does not stop there. Service Manager actually is considered the very heart of Microsoft's System Center environment. Now, the reason for this is Service Manager under the hood is Microsoft's Configuration Management Database, or CMDB. Now, CMDB's purpose in life is effectively to have that one single repository of knowledge that understands everything that is happening in our environment. It has a knowledge of all of our users, all of our groups, all of our computers, all of the issues that have happened on those computers, all the problems, the changes, the updates. Everything that happens in our environment is recorded. Now, normally as we start as an immature IT operation, we think about things like configuration databases, and we will have lots of them. Maybe a spreadsheet to maintain a list of our IP addresses, a spreadsheet to maintain a list of our servers, a spreadsheet or a database that lists off all of our different desktops in each location. Maintaining that spreadsheet or database becomes a mundane task which, within a short period of time, is out of date. And then we have a much larger problem of going back and reviewing our assets lists and getting it back into spec and ensuring that that database is again referenceable. Then we have a consistency issue because if we're working in an environment that there are multiple locations and we've got multiple staff helping us to maintain these for the different locations, there's a very large potential possibility that different staff in different locations will make a modification to that spreadsheet as they have relevant information to them that they believe should also be retained, or worse, make a decision that some information in the sheet is not relevant to their location and leave it omitted. In the System Center Service Manager configuration database, the database is shared across all of the System Center stacks. And as we take a look a little bit later on, we're going to take a look at how this database is maintained automatically. And I'm going to stress that word. This database is maintained automatically, meaning that once we set it up and configure it, it will work to make sure that it is at all times up to date and a usable reference. As IT, we then have the ability to extend that database. We can add more types of resources in an object-oriented fashion, which simply means we think of all of the types of resources that we're using, class them as types of objects for classification, and extend the database to state that we're going to host this type of information. So maybe, for example, in our data centers, we might have power distribution units or uninterruptible power supplies. These type of information we may want to add to the CMDB so we can extend the database to hold these classes of objects, classes of equipment. Now beyond the CMDB and beyond the ability for requesting services and doing things, service managers' real focus is to drive behaviorisms. We put a request into IT to create a mailbox, expand a drive, request a new piece of hardware. And as a result, a human is likely to take a look at that request, review it, and hopefully action it. But Service Manager understands that some of these requests might not just be unusual. They might be repetitive. They might be extremely repetitive. For example, HR has just hired a new person, and therefore we need to create a new object in Active Directory, and we need to provision a mailbox for that user. This is a repetitive process, a process that we're all very common with. So to help with this, we have yet another component sitting in the System Center stack. And this component is Orchestrator, an automation engine built on a Visio-style interface. System Center Orchestrator, or SCO as it is more commonly or fondly known, is a utility that was introduced with the System Center 2012 software packages, and its task is to allow non-technical IT people with very little programming skills the ability to design in a Visio-style interface a workflow utilizing activities to essentially make things happen. Now, this is extremely powerful. The idea of having an IT person write an automation without any knowledge of a scripting language by simply dragging a flow onto a canvas and then providing some properties about that flow. For example, I would like to create a new AD object, so I will drag from the canvas the idea of a new object. I will provision properties, for example, the name, the full name, the logon name, and I'll also go ahead and define locations in the directory where I would like that object created. I'll check to make sure that that object was created successfully, and if it was, then I'll have another item on my canvas which may suggest that I should create a mailbox, and then maybe even send an email to that hiring manager to let him know that this process has completed The icons are the objects that we utilize, which are fondly known as activities in this environment. These are extensible using what are known as integration packs. Integration packs can be self-written. They can take existing functions and they can be wrapped into an integration pack. And there are many third parties making them available, both up on Codeplex or for small nominal fees. And these integration packs allow us to communicate with devices that may include our F5 load balancers or maybe Microsoft's identity management tools or just about any other pieces of software you may contemplate adding. And in the scenario that there is no integration pack available, you have the ability to always fall back to PowerShell or C Sharp as programming languages and have your developers work with you to create an activity. And those activities can then be stored in your library so that once they have actually created that extensible script, which might be 1 line or 1,000 lines, you can then forevermore pull that onto your canvas and use it in any of your runbooks that you create afterwards. Now, a runbook is essentially that canvas. It is effectively the drawing that you've just created. So each drawing is considered as a runbook, and your orchestrator environment can contain many multitudes of runbooks doing all sorts of different activities. For example, adding a new node to a load balancer, draining a mailbox and shutting down a user's object, creating a new user into the environment, running a scheduled task to validate a file share has no log files older than 7 days and moving those out to archive and deleting anything over 4 months. All of these different type of processes that become repeatable, these become a library of different runbooks that can be triggered in many different ways. One of those triggers is an interface that is known in the programming world as an OData REST interface. This interface is essentially a web-based method to actually ask Orchestrator to do something. Now this is very, very important because REST or OData or JSON, as three of the main technologies we'll talk about as we move forward, these technologies allow us to communicate with System Center in a firewall-friendly, internet-friendly, secure manner. Not only can we tell System Center to do things, we can ask System Center to inform us. An orchestrator can essentially allow us to provide that type of an API so that our developers or other products within the System Center suite can start communicating to each other. We'll take a much closer look at how this works. And finally, like the rest of the System Center suite we've seen so far, Orchestrator also is delivered with its own console. It allows us essentially to deliver a self-service experience to different staff and control their access. So for example, you have a requirement to offer BitLocker services, especially to your help desk guys, but you do not want to go to the trouble of doing all the delegations in Active Directory. You can now provide a web portal through the orchestrator environment that exposes just the runbook who you've just coded to go ahead and query the BitLocker information from Active Directory for the machine name that the help desk person has requested, and in return send them back the results of this query without delegating securities and without compromising any other services in the environment, and ensuring that the inputs that the help desk team provide is only those inputs that are of any relevance or value to them, and restricted essentially to machines that maybe they have the privileges to get the information for. Now, one of the old timers in the System Center suite is Operations Manager, SCOM, maybe one of the more better known products in the suite. But Operations Manager probably will be better known as Operations Monitor, for its historical purpose in the System Center suite was essentially for monitoring and alerting the health of all of the systems it has agents deployed to. So using an agent, it pushes out a little piece of software onto the target machine, Windows or Unix based. It's essentially irrelevant in 2012. And utilizing knowledge packs, known as management packs, System Center can query and discover and learn all about the technology that's running on this server, feed that information back to us, and in leveraging additional information in that management pack, make decisions on whether the information he's feeding back to us is actually of good or of bad status, and alert us based on its inbuilt knowledge. This knowledge is generally delivered directly through product groups, so it is quite normal for any product coming out of Microsoft to also have a management pack made available to it. So the product groups will be defining exactly the type of information that is relevant to be gathered, but much more importantly, the type of information that they can highlight that would be an indicator to a problem or a perceived potential problem, and alerting us then into four main areas of either a problem that may affect configuration, may affect performance, may affect overall availability of this particular service, or may actually have security implications, allowing us then to make some decisions based on who we send these notifications to and what we do with them. So for example, we may not want to bother our help desk team with security related alerts, but we might be very important to make sure that anything performance or availability related is routed to the help desk, who can then make a decision: should they open a support ticket, should they call an engineer, or can they automatically fix it? And this is where the manager piece comes into play, because in addition to the knowledge of monitoring and the knowledge for alerting, operations managers' management packs also come with a set of tasks allowing the engineers who are leveraging Operations Manager to execute procedures, to make changes to the environment that will help to resolve the system and get the system back to normal. These tasks are also working quite similar to the way we looked at our scenario a few moments ago for BitLocker in Orchestrator. These tasks, although offered to a potentially junior IT help desk engineer, may require root level or sysadmin level access to the service in order to resolve it. So the tasks will run under the security context that is defined in the management pack and through the proper security roles that have been set up in Operations Manager. Once more, ensuring that we can delegate safely and securely access to the services with the specific tasks only that we wish our support teams to have, allowing us essentially to make sure that our operations are online and running at all times. Finally, of course, operations isn't just about the IT team and the help desk team. It's about our senior management, our CIOs, our CXOs. This essentially is where we can start rendering back information about the services that we deliver. An operations manager is a monitoring tool that thinks about the service, not specifically about the server. Therefore, we can start talking about the service levels that we have for our messaging, for our authentication, for our business applications, and allowing us also to deliver diagrams of how these applications look, so that we can take a very quick, high-level executive overview of not just our business services, but drill into those business services and see what the key components are and what are the relationships between each of these services. Something that is important to us to ensure our operations are running well, but also very key to the information that we hold in our configuration management database that we have over in Service Manager. We can start to see analogies starting to build here. Now, we'll introduce another component in the tool, and this one is Configuration Manager. Configuration Manager is yet again different. Its focus is more outside the data center than inside the data center. Although, that said, configuration manager is very often found in the data center, running, maintaining, and supporting the data center. But its job is primarily to manage clients, servers, and devices, making sure that they've got operating systems, distributing applications to these things, ensuring that applications aren't breaching licensing, and having a configuration database for what these different applications are, and more importantly, delivering desired configuration to these nodes, ensuring that the proper versions of files are in place and letting us know if that isn't the case. Management through Configuration Manager, just like we've seen in Operations Manager, is once more again agent based. A little agent runs on our target machines, and that agent allows us to deliver policies, to deliver packages of applications, and to understand if there's activities happening in that node, and allow us to again gather up the information. Tell me about how that hardware is configured, what's sitting inside the chassis. Has the chassis actually been opened? What applications are running there? And all of this in 2012 is based on user-orientated focus. We deliver an application to a user, not to his desktop. So the CIO walks in, tells you he needs a new copy of Visio. You scramble and say, what machine is a CIO? Can I go into his office and push off the operating system, log in and give him a new version of Visio? Only to find out 20 minutes later that the machine that was sitting on his desk wasn't actually his. It was just another manager that happened to be in his office. Oops. In Configuration Manager, all of that disappears. We log in, we found the CIO as a user, and we assign the package Visio to that user. We can configure that package to be auto-deployed or manually deployed. So when the user then sits at his device and logs in, that package will be presented. The method of presenting the packet might be a full install, it might be a virtualized version of the application, it might be a very special version of the application because the device that he's running on may, for example, be an iPad or a Mac and not a PC. So therefore we may need to have a specific distribution of that operating system delivered. We may not even deliver the operating system. We may give it to him as a remote application and he does an RDP connection. All of those decisions are made by us, the administrators, and we deliver the applications to the users, not to the hardware. And that allows us then to start contemplating the fact that people can bring their own devices and start delivering services out on a basis of the role of the user rather than the role of the devices the user may have. Configuration Manager is not unlike any of the other tools. It also comes with its own web portal. And this web portal is actually focused again on self-servicing, this time as an application catalog for the users, listing off all of the applications that we may actually have published or decided to publish publicly to our user base, giving them the ability to make a request for that software, which in turn gets sent up as far as Configuration Manager, and then with the correct approvals from line managers or operations managers, that application can then be released, assuming licensing and everybody is happy, to the user for automatic deployment. Now there's one more anagram I'm going to call out, and it's an anagram that's kind of started to fade away, EPM, or Endpoint Protection, sorry, EPP. System Center's Endpoint Protection is now fully integrated since System Center 2012 directly into Configuration Manager, adding essentially as an additional service of Configuration Manager. However, there are times when EPP still gets listed out as an anagram of its own. Its purpose is specifically for providing antiviral and anti-malware services as part of the System Center Configuration Manager agent, dealing with outbreaks and alerting all of the resources that are necessary through the Configuration Manager design systems. Now the final system we're going to take a look at in this particular pass is DPM, Data Protection Manager. The Data Protection Manager is Microsoft's backup tool. So we've seen quite a lot of tools at this point between virtual machine and fabric management, a portal that's been essentially removed through App Controller, Service Manager for dealing with ITIL type processes, automating and managing users and supporting CMDB services, Orchestrator, a visual designer essentially for writing workbooks and run flows so that we can make things happen automatically and repeatedly. Operations management for monitoring and managing our environments. Configuration manager for deploying and maintaining the configuration operating systems on our desktops, clients, and operating systems, delivering applications and protecting that machine from virus and malware breakouts. And then finally, data protection manager, the backup tool of the System Center suite. Again, utilizing and leveraging agents, data protection manager is completely different from pretty much all of the other data backup solutions, and that is its primary backup is to disk. Data Protection Manager is fully integrated into Microsoft's application suites of SQL, Exchange, and Hyper-V, able to make consistent backups of these devices in a clean and proven manner, but also provides a very rich self-service experience where the users can actually request that a backup be executed, or more importantly, a user can actually ask for a restore of an item from a backup. And again, with or without approvals, depending on our configurations, those items can be restored to alternates or to the original destinations, all directly from disk. And where necessary for archival purposes, Data Protection Manager also supports the ability to move stuff off to tape. And Data Protection Manager in its 2012 R2 incarnation has the ability to deliver those backups directly to the Azure cloud, up as far as the storage blobs in Azure, making even easier restores possible for resources in test clouds or back on premise to make sure that we have everything that is necessary for complete self-service automated data protection. Like everything that we've seen before, Data Protection Manager also gets involved in the idea of integration with the rest of System Center. So what makes System Center so different? Because we've seen essentially at this point the fact that System Center is, well, it's a collection of different applications with pretty funny anagrams, long names, and sometimes not very descriptive names. But that's not much different from looking out at third parties or yellow pack products, which essentially have very similar feature sets and function sets. The thing that sets these apart is connections. Microsoft have gone out of their way to ensure that this suite of components can act as one. If we start with our basic environment with Active Directory, Exchange, SharePoint, our line of business applications, our users, the fabric that we run on between the storage, the networking, and the compute, and we start thinking about deploying these different components, we don't be long before we've turned up with a hive of different pieces of the puzzle. System Center, Virtual Machine Manager, Data Protection Manager, Configuration Manager, Endpoint Protection Manager. All these things start to build a big honeycomb of different pieces of kit or puzzles. Nothing really unusual. Each of these will deploy agents with the requirement for the agent to interact with the target operating system on Windows or Linux and gather in the knowledge or execute the configurations on the fabric or do a backup of the actual device or ensure the configuration is as required. But then things start to change. We get the introduction of connectors. Virtual Machine Manager and App Controller. These two things are one. App Controller is the web portal that offers us the ability to manage our self-service cloud and Virtual Machine Manager. So it makes a direct connection. It understands the APIs and knows how to talk. It also knows how to talk to Azure. We look at Configuration Manager and Endpoint Protection, two products that used to be two separate entities, then got connected, and now we're so connected they're essentially integrated and we no longer even contemplate them as two different products. Take the heart of the environment, Service Manager. We have our CMDB, and the CMDB needs to know if something's happening on a workstation, so we get a connection from Configuration Management. The CMDB needs to know, have we got an alert on one of our business services? Operations Manager communicates with us. Virtual Machine Manager deploys a new virtual machine to the environment. It updates the configuration management to Service Manager. It tells Operations Manager that this VM is online and running. Service Manager needs something else to happen for us so it can orchestrate. It makes a call directly out to orchestration. The connections that start to happen when we look at Service Manager and the rest of the System Center suites quickly become the differentiators, which allow System Center to be the component that allows us to build management scenarios with one or more. And as we've seen at this point, we have a very clear understanding of what these components do. Now we start thinking about what and how we make these come to life in our worlds. Now, as I mentioned a little earlier, a number of these components are changing. App Controller, for example, has gone essentially to the graveyard, and it's been replaced with this thing called Service Provider Framework, SPF, another one of these anagrams that we didn't even talk about. Service Provider Framework is a REST API. That's something we talked about when we listened to Orchestrator. So there is actually no web portal for Virtual Machine Manager in the new world. There is just an API endpoint. That's not much use. Or is it? Well, if we've an API endpoint, we can introduce another component, something new, something free, something called the Windows Azure Pack. Windows Azure Pack essentially allows us to take on-premise and deliver a HTML5 experience as self-service to our users. And in this particular case, this self-service experience is exactly the same experience that we get if we're using Microsoft's public Azure services. It is the communications to the Service Provider Framework API, making it completely firewall friendly. We can run Azure Pack in a secure environment, and across the firewalls, we can then communicate to Service Provider Framework, which in turn will communicate to Virtual Machine Manager, and if required, can communicate to any of the other components within the suite. Orchestrator. It's also getting a little bit of a change. Under the hood, Orchestrator now ships, since the SP1 version of the Orchestrator product, a second automation environment. This time it's called Service Management Automation. Service Management Automation is a workflow engine built on top of PowerShell. Now, PowerShell, we all know, is Microsoft's main investment in automation technologies. So, following the abilities of what we had in Orchestrator, Service Management Automation as it stands today is a PowerShell version of the runbook engines, and it fully integrates again to Windows Azure Pack while maintaining its Service Manager and other bounding connections. And given that this thing runs PowerShell, it therefore has access to all of the hundreds of PowerShell modules publicly available and of all the scripts that exist. But makes things even more special in the workflow scenario, if our servers that are running the workflow should for any reason be shut down, those workflows essentially will suspend and resume where they left off when the systems come back. Now, as we finish up our look at the connections that happen within Service Manager and System Center as a whole, we'll spend a few moments just to talk about Windows Azure Pack and just understand where the last of these connections happen and why Windows Azure Pack has occurred. Windows Azure Pack makes things slightly different because Windows Azure Pack delivers a self-service experience to the users. But that self-service experience expands well and truly beyond what is inside the System Center world. It allows us to deliver websites built on top of Windows using the IIS web farms and exposing it as a no data endpoint. It allows us to build our virtual machines, something that the virtual machine portal existed for and then App Controller existed for, and now, following the same processes of Azure, we now can do this in the box with Virtual Machine Manager. Windows Server talking to System Center Virtual Machine Manager through the OData API that is the Service Provider Framework. We can deliver databases, self-service database to our users. We can continue and we can make a connection back to the SMA environment using standardized OData connections, and we can even deliver message queuing services or service buses. All of these deliver up into one single unified API, which happens to be REST OData. And on top of that, we build a brand new portal, delivering a brand new extensible and connection process for our users. So, what we've really looked at over the last 30 minutes is the building blocks that is the Cloud OS, that is Microsoft System Center stack, and that is the enabler for us to deliver lots and lots of different management scenarios. Let's take a look at the heart of the environment, and we're going to start in Service Manager. I'm in the Service Manager Administrator console, and I'm looking at the connectors. This essentially is the feed that allows Service Manager to start understanding what is happening around it. Service Manager gets its feed from Configuration Manager, Operations Manager, Active Directory, and Service Management Automation, Orchestrator. Lots of different components and lots more connectors we can continue to add. Software metering, alerting, virtual machine manager. Connectors that allow the configuration database to start building up a repository of knowledge. Now, one of those repositories of knowledge might be about our business services that we run. Business services, something that we may not be taking really seriously in a small environment where we've got potentially 100 through to maybe 500 different servers running, and we've got this down pat, so we don't really need to worry too much about services. We can maintain, we know what the servers are, we feel sort of confident. But the reality is, if a server in that group goes down, some members of the team will have very clear confidence saying, don't worry, it's fine. Others, however, not being completely acquainted to that environment, will panic and say, oh, sugar, we need to fix this rapidly because this could be really important and we may have serious business impacts. It's that knowledge of what units build the service that we need to maintain. And when we switch over to places like Operations Manager allows us to author things. Operations Manager introduces the concept of building distributed applications. Those applications can be anything from internal solutions like Link or Exchange, or business-specific solutions, which might actually represent our applications we build in our business. Now, what makes these quite interesting is that these applications allow us to start discovering what servers exist, what roles they play, and how critical they are in those roles. It also helps us to start building a concept of what is the availability for this business service when we deliver a dashboard back to our administrators or to our CIOs to basically say at the end of the week, we've delivered 99.9% uptime. We've had 6 outages on 4 Exchange servers with 0 business impact because these were through scheduled maintenance or potentially even unscheduled maintenance. But our environment has been built in a scalable fashion. It also means that in this scenario, we have quite a lot of options around effectively ensuring that the knowledge that is necessary is distributed and available to everyone that is essentially involved in what may or may not be happening in the environment. And what allows us to draw in or draw out of that environment, digging in to see exactly what's happening. So for example, in this environment, I can see that I have a problem on my hub. I can take a closer look to figure out why and what's causing the issues. So I've got a number of issues around critical, and I can see that I have an edge sync failure happening. And if I take a closer look, I can see exactly where that edge sync is happening and resolve those issues. This information can then allow me to make some business decisions if I need to actually go ahead and call an outage, wake up an engineer, or make things important to me. And this is where the connectors to Service Manager really come into life. Because in Service Manager, as with Operations Manager, this knowledge is stored in what we refer to as management packs. Management packs effectively allow us to keep the configuration information, the discovery information, and the knowledge of our environment, and essentially enable us the ability to package and prepare that information in such a way that we can move it from different environments, for example, development to staging to production. But through their portability, we also can take those management packs and bring them over to the CMDB, teaching the CMDB about the services that exist, the nodes that exist in those services, what they're doing, how they communicate, what is happening. I can still see my link environment and understand the nodes that exist on those. That makes its way through to what is essentially in the configuration of our Service Manager world. And under Service Manager, I can see I have business services, and those business services are based on the systems that we defined within that configuration. I find each of these services, I can define who owns the services, what is the SLAs, who needs to be alerted, and I can use that information to make decisions based on if I have an outage notification, who's been affected? Who do I actually need to notify and let them know that there's an outage? Is this a critical outage at a weekend? Should I be getting engineers online, or is it okay to wait until business hours begin on Monday morning? I can also come back and I can historically look at the history for this particular service. Operations manager has been telling me that it's had this problem with edge synchronization. I've opened 6 tickets on this over the last few weeks. I can take a closer look and I can actually see that the help desk guys and about 400 other users have been complaining about mail flow problems. And I can start building a picture using the configuration data that's been coming in both from human and from system and from System Center's configuration manager also. So I can even check to see, was there a new service pack deployed on that machine in the last few weeks? Maybe that has had an effect on when the issues have begun to rise in the environment, and therefore I now have a much faster view of what's happened, even if I'm not the subject matter expert for this technology. Now, on the opposite side of that coin, we also have orchestration. Now, orchestration allows us to take a closer look at a canvas, as I mentioned earlier, that uses components or activities to drop on a piece of a runbook and essentially allow us to do things. Now, in this particular case, the canvas simply asks for the computer and the user ID to send the information back to. This particular runbook is getting BitLocker details. Now, of all of the different activities that exist, I don't actually have an activity here that says get BitLocker information. I've got stuff from Configuration Manager that will tell me things. I got stuff to tell me about Operations and Service Manager, about Virtual Machine Manager to build clouds and virtual machines. I can even tell it go build me a mailbox or tell me how many emails are in a mailbox or move a mailbox. But what I can't do is actually find out about the BitLocker keys for a computer. So to fix that, we talked a little earlier that we can create our own activities. Those activities are quite simply PowerShell. And in this particular case, you can see I'm just using basic PowerShell. Go to Active Directory and write a function to get the BitLocker information. That information then gets published. The results of it essentially get published back to what is known as the pipeline, the link between the different things. And that pipeline then results in making additional steps. So for example, I want to make a note that somebody's requested because I want to do security audits later on. And of course, then I need to actually send an email. And if I take a look at the email I'm sending, I can say, here's my BitLocker information for the computer name that you provided me. Who am I sending the email to? And what is the message that I'm going to put into that? And that, of course, is going to be the results of the BitLocker details that I've pulled from the script. So the whole idea of building a process of automation becomes far simpler for us to deal with. Now, as we start looking closer at how automation works, and we're going to do that in a few hours' time, where we're going to spend a full session talking about operations and automating those operations, we'll get a much better idea of just how integrated the orchestration and service management engines really do become within the environment. Until then, we'll take another look at one of the components, which is the first component we introduced, Virtual Machine Manager. And Virtual Machine Manager, through its fabric view, we can quickly see the systems that exist. And there's configuration information in these systems. If I take a look at any one of these environments, I can learn much more about how this device has been configured. Is it compliant? Do I have communication faults with it? How are the networks configured on this particular device? Maybe I'm interested in what virtual machines are running on this device. Switching my views allows me to take a closer look at the actual virtual machines that are hosted throughout the environment. What clouds have I got? Are there different virtual machines running on those clouds and what hosts they sit on? Was the job status for these successful? And more importantly, the operating system. All of this contextual information gets delivered through the connectors the whole way back into our service manager. So by simply switching our administrative view on Service Manager and building a brand new connector over to a Virtual Machine Manager, I can start educating the configuration database even more about what's happening in the environment. The remaining area that we haven't taken a massive look at happens to be that of configuration management. Configuration management can be utilized in or outside the data center and is responsible for most of the key areas of user assets, software, compliancy, and as we mentioned already, our endpoint or antivirus. Here I can actually take a close look at not only the antivirus but the firewalls, but I can see this across every single device in the organization. Is the device active? Is it on premise? When did it last communicate with me? And what type of software has been deployed to the device. I can take a look at my software library. I can check the monitoring of the environment and make sure things are working the way they need to do. Are there software updates that need to be deployed? Do I need to deliver a brand new operating system, boot images, or just generally pre-configured images that are good for my specific brand of operating system hardware that I'm delivering within the organization? As a new machine gets deployed, then I will also learn very quickly about who's using it, because the user information of the workstation is something Configuration Manager learns very quickly. He understands who's logged on to that machine, and I can start building a representation. When I come back to Service Manager and I go to the decision to make a new incident, when I create that new incident, I can turn around and I can create the incident for Damian. And immediately when I get my list of associated devices, Service Manager already knows that the devices Damian works on happens to be the ones that Configuration Manager has just told him about. So those are the ones that are made available to me initially to pick from to say, is it one of Damian's normal devices that you're having this issue on? So if this software installation that I'm writing a ticket for, I can quickly start building incident maps. I can then utilize that information to turn around and say, Damian has opened 12 tickets. Out of those 12 tickets, 8 of them have been always against software, the software being Office for argument's sake. But more importantly, they've all been against his little old Dell workstation that happens to be 8 years old. Maybe it's time that we take a quick look at the fact that he's costing us time and energy supporting this device. And maybe the total cost of ownership is something we need to deal with now, because at 8 years old, it's past its depreciation levels. So the cheapest fix for us right now, instead of supporting Damian, is to actually get him a new piece of hardware. And therefore, all of the requests and support tickets he's placing in, those become redundant because they no longer become associated to that device. The management systems and options that you get with System Center are flexible. And that is one of the key things to take away as you start your course through the rest of today's presentations. System Center is built from components for a reason. It is modular. You pick, you select, you choose the components that are suitable for you today. You build the connectors you believe you need now, and you add the rest later. I've shown you in my demonstrations here that I have got connectors to different systems, yet I have no connectors to my virtual machine manager environment as yet. Those decisions you'll make based on when you're ready You may make a decision that I would like Virtual Machine Manager send me back a list of all of the clouds so that I can have a list of the clouds that Damian has. So when I go open my next ticket to say that I need a new cloud, I can quickly get an evaluation back saying you've already got 4 clouds. Why do you need a 5th one? You've got 65 virtual machines running on those 4 clouds. Do you really need another one? And you can deliver this context information to our users in a secure and manageable fashion. So, as we prepare for the rest of the presentations today, start with the knowledge that System Center, although is built from a whole lot of anagrams, is built on the concept of customization. You have the ability to make a decision for what it is you want to deliver today. It is up to you to understand, design, deliver, and implement the System Center solution that is right for you. We're going to help you make those decisions. So over the course of the next number of presentations, we're going to dig into how to get System Center implemented in your environment quickly and easily and painlessly. We're going to look at how you can deep dive into things like monitoring and management. We'll take a look at how you actually automate those processes. And we'll essentially show you how you choose from that cherry tree, what are the ones I want to start with. Take small bites of the apple, get it right, and then come and take another one. Join it to the environment, start leveraging the benefits and the beauties you get as you start putting these together. And before long, once you've got the first 2 or 3 modules into place, the rest of them become very inherent and you understand more and more of how the value of System Center and how the Microsoft Cloud OS becomes one. And that's all before we even take a look at what is available in the public Azure services that tightly integrate. Later today, you'll see some presentations on Operations Manager. We've talked at the very start of the thing called Advisor. Advisor is now being renamed as Application or Operations Insights. Operations Insights is a cloud-based service to communicate with your workstations to figure out what's happening on those. Send me back the audit logs, pull them together so I can analyze the logs and some of the information that I would collect in Operations Manager and alert me based on the fact that there is unusual logon behaviors or we have a trend going on to show that we're going to run out of storage, or we have a trend showing that over the last few hours we started getting more and more alerts on these specific issues from Service Manager. This type detail comes from the power of the cloud. Tightly coupled with what we get in the products today, your building block starts now. Your building block starts right here, and your management knowledge that you gain will never stop growing because System Center will never stop evolving. My name is Damian Flynn. I hope you've really enjoyed this introduction to System Center, the components and the building blocks. You have a better idea of how these management blocks pull together, what they are, so that you have an open mind of what it is you can do to make System Center power your environment. Stick around for the rest of the day. Keep an eye on the rest of the videos in this series. And by all means, make sure you keep an eye on Twitter for the UK MVP Cloud discussions. If you're interested in the MVP program itself, check out the MVP websites. You learn much more about the MVPs as we exist here in Ireland and the UK, and of course the rest of the world. Jump up and grab your free copy or access to Azure. And if you do really want to get back in touch with me to learn more about any of these things, then please feel free to tweet me, mail me, or just check out my blog. Thank you very much for your time, and we'll speak again soon.